Yes. Good evening all. Please do chat with me so that I can understand that you are with me. Good evening. Yes, please chat with me. Yes, please do chat with me, so then only I can understand that you are there. Is my voice audible for you all? Hello? Is my voice audible for you? Yes, okay, right. Okay, now listen. So today we are going to deal with the topic. Actually, we are going to discuss the revision portion, that is matrices. Now listen. We are dealing with multiple choice questions. Let's solve the questions one by one. Of course, you need to chat with me. If you are getting an answer, please do reply with the option number or option letter. If it is A, B, C, D, you just need to reply with the letter A, B, C or D. That's enough. After that, I will explain. So initially, I will provide a question for you, and I will provide approximately around 35 seconds for solving. After that, please do reply with your option. After that, I will explain. This is the procedure we need to follow, right? So let's start. Are you ready for that? I am patiently waiting for your reply, because chatting is the only source for communication. Please do reply. Good evening, Sudesh. Good evening, David. If you can hear my voice, please do reply. Yes, I hope you can follow what I am saying. So let's start discussing the questions one by one. Here goes the first question. Matrices, you know what this topic means. Normally we start with how to find the orders. You know that number of rows by number of columns, that is the order of a matrix. After that, we will deal with, we know that we deal with the square matrix, diagonal matrix, column matrix, row matrix, like that. Identity matrix, what we mean by identity matrix, it has diagonal element 1. All the non-diagonal elements are 0, right? So like that, after that we deal with the next portion, that is matrix addition, matrix subtraction, matrix multiplication, a scalar multiplication, like that. After that we deal with the symmetric and skew symmetric, right? So listen, I am just giving a small idea about symmetric and skew symmetric. If a matrix is given as A, for example, a matrix is given and named it as A, and we need to frame a symmetric matrix. The best possible way is just take the transpose of the given matrix and add the transpose of the matrix with the original matrix. On adding this, we will get, yes, on adding this, we will get a symmetric matrix. Remember that if a matrix is given, take the transpose of the matrix. Transpose means you need to change the row to column, column to the row. Okay, you can do any one frame to find the transpose. After that, what we need to do is, yes, it is A and this is A transpose. Just add this. On adding, you will get a matrix named it as, name it as P. For sure, the matrix P will be symmetric matrix. What we mean by symmetric matrix? That means on taking the transpose of this matrix, you will get the same matrix. For example, I will solve a frame like that. Listen carefully. This is very important for MCQ frame. That's why I am explaining this. Listen, I hope you all know this, but I am just giving you an idea. Listen. For example, a matrix is given as 1, 2, 3, 4. Okay, so this is A. And I am taking A transpose. A transpose means I am just changing the row to column. So this becomes 1, 2 and this becomes 3, 4. And just add this. On adding, you will get a matrix. I am naming it as P. Just add this. We will get P is equal to, yes, 1 plus 1, 2, 2 plus 3, 5, 3 plus 2, 5, 4 plus 4, 8. We got a matrix, right? Just take the transpose of this matrix. That means just take the transpose, P transpose. What is P transpose? Yes, 2, 5, 5, 8. No change, right? Both are same. That is P is equal to P transpose. That is what we call as symmetric matrix. And if we need to frame a skew symmetric matrix, how it is possible? That's also very easy. How it is possible? That means just take A, take the transpose of A. Here we added both. To create a skew symmetric matrix, just subtract these two. As a result of that, you will get the frame. Clear? Right. So similarly, you can name this as Q. You will get a frame, and we know that skew symmetry means on taking the transpose and on taking a negative sign, we will get a matrix, the same matrix. That is what we call as skew symmetric. We all know that, right? Then after that, we deal with the inverse of a matrix, and I hope you know all these frames. Based on this, we are going to discuss the MCQ questions, and here goes the first question. Please read the question. Please try to note this question, and please reply with the option number. Okay, option means here I will provide it as A, B, C and D. Just reply with A, B, C or D. After reading the question, give a try. A very easy question, and your time starts now. Yes, time up. And Nevin, you got the correct answer, very good. So listen, if a matrix has 6 elements, the number of possible order of the matrix can be. You know how to find the order, right? For example, if I am considering a matrix like this, 1, 2, 3, right? This is a matrix of order. We need to count the number of rows as well as the number of columns. Here the number of rows is only 1 row, so 1, and number of columns 1, 2, 3. So this is a matrix of order 1 by 3. From this frame we can say that if this is a matrix of order 1 by 3, it has 3 elements. We can simply calculate by just multiplying these two numbers in the order. 1 into 3, that means 3. So that means in this matrix it has only 3 elements. What is the question? If an element has 6 elements, then number of possible orders of the matrix can be. We need to find the possible number of matrix. Listen, it's very easy. Actually, to get this 6 as element, here we know that 1 by 3, 1 into 3, so it has 3 elements. So in order to get 6, the possible orders will be, one is 1 by 6. This is one possible order for the given matrix, correct? The second one is the reverse of that, 6 by 1. This is also another possibility. In these two orders, for sure, the total elements in these matrix will be 6, like that. I can take the next possibility. Yes, to get the 6 element frame, the next possibility is 2 by 3. 2 by 3, 2 into 3, that is 6, correct? Similarly, we can consider this next frame also, that is 3 by 2. Is there any other possibilities for getting the element count as 6? Listen, 1 into 6 is 6, 6 into 1 is 6, 2 into 3 is 6, 3 into 2 is 6. These are the only possibilities. So for this question, only 4 orders are possible. So for this question, the answer is B, 4 answer. I hope it is clear, right? Is that clear for you all? Okay, right, okay. So I am moving on to the next question. I hope this is clear. So let's move on to the next question. This is the question, another 35 seconds time, and your time starts now. A simple question. Please do reply quickly. Okay, again very good, Nevin. The answer is correct. Let me solve another easy question, right? Listen the way I am explaining. Yes, if A is equal to matrix Aij is a 2 by 3 matrix, clearly given that it is a 2 by 3 matrix, that means it has 6 elements, right? Okay, such that Aij is equal to, I am considering that frame over here, listen carefully, that is Aij is equal to I plus 2j the whole square, the whole by 5. This is the frame. Okay, and what they asked to find, we need to find what is A23. That means in place of I it is 2 and in place of j it is 3. So we need to find A23. Just substitute the value for I as 2 and j as 3. That's all required, right? We know that this is the frame to find the elements in a matrix. This is the frame to find the elements in the matrix, and A23 is the second row, third column element. Correct? There is only one element in that position, and that element is what we are going to find. Listen. So minus 2 plus 2 into 3. In place of j, it is 3, right? 2 into 3 is 6. The whole square, the whole by 5. Okay. Now listen. A23 is equal to minus 2 plus 6, that is 4. So 4 square by 5. What is 4 square? That is 16. So 16 by 5 is the correct answer. So for this question, D is the correct answer. I hope it is clear, right? So please note this. After that, we will move on to the next question. So the next question, yes, third one. Read the question carefully and try to answer the question. Simple question. Solve it yourself. Simple question. Remember that comparatively the chapter matrix will be easier for you. So you should know some frames to find the answer, that's all. Just give a try and reply quickly. Maybe this will be confusing for you. I will explain this. Listen carefully. If A is equal to diagonal 3 comma minus 1, then matrix A is. That means clearly given that it is a diagonal matrix and it has elements 3 and minus 1. So if I am considering A, if it is a diagonal matrix, what that means? It has only diagonal elements. That means the non-diagonal elements are 0. The non-diagonal elements means this is the diagonal, right? So we need to consider this 3 and minus 1 in the diagonal frame. The remaining frame will be 0. So that means A is equal to 3, 0, 0, minus 1. That is the answer for the question. And for this frame, the correct frame, it is option C, 3, 0, 0, minus 1. I hope it is clear. That was a simple question. Diagonal elements are clearly given as 3, minus 1. So if it is 3, minus 1, that means it is a 2 by 2 matrix, because for a 2 by 2 matrix or a matrix of order 2, a square matrix of order 2 has only 2 diagonal elements. If it gives us 3, minus 1 and another number 5, assume that it is 3, minus 1, 5. That means it has 3 diagonal elements. If it has 3 diagonal elements, for sure a diagonal matrix is a square matrix, and for sure to get 3 elements in the diagonal, it should be a 3 by 3 matrix. Like that, if it has 4 elements diagonal, that means it is a 4 by 4 matrix, like that. I hope it is clear, right? So let's move on to the next question. This was an easy question actually, maybe little confusing, but remember that this is very easy. So let's move on to the next question. Here goes the question. Solve it. Okay, Nevin, now listen. Correct. Time up. I am going to explain this. Listen. If A is a square matrix such that A square is equal to A, then I plus A the whole square minus 3A is. Listen. I means we know that is identity matrix, correct? So clearly given that if A is a square matrix and A square is equal to A, that's very, very important. That's an if condition given. Then I plus A the whole square minus 3A. What is the value for this? This is what we need to find. Now listen, this look like A plus B the whole square. What is A plus B the whole square? A square plus 2AB plus B square. I am using the same frame. A square means I square, right, plus 2AB, 2 into I into A, 2IA plus B square, that is A square minus 3A. And we know that the square of an identity matrix, that I will explain. Listen, if you consider an identity matrix 1 0 0 1, I square means we need to multiply this 2 times, 1 0 0 1. On multiplying, what we will get? Yes, I am multiplying this 1 into 1, 1, first row, first column, right? 1 into 1, 1, plus 0 plus 0 0. Again, first row, second column, 1 into 0 0, 0 plus 0 0. Here, second row, first column, 0 into 1 0, plus 1 into 0 0. Then second row, second column, 0 into 0 0, plus 1 into 1 1. As a result of that, we know that you will get again an identity matrix. Correct? Sorry, identity matrix. So listen, the square of an identity matrix, for sure it will be an identity matrix. So this will be I itself, no change. Plus identity matrix into a matrix, that will give the same matrix, no change for that. That is IA is equal to A. We know that IA is equal to A, right? And identity matrix into a given matrix will be the given matrix itself. So 2 into identity matrix into given matrix means the given matrix A itself, plus A square. Clearly given that you need to put A square is equal to A. So I am putting in place of A square, I am putting A minus 3A. So which is equal to I plus 2A plus A, that is 3A, minus 3A. What happens? Plus 3A and minus 3A cancels out. As a result of that, the final answer becomes I. So for this question, A is the correct answer. I hope it is clear, right? Remember this very important question. Note this. Can I shoot out the next question? If completed, please do reply. Okay. So, the next question, please. Simple question. If you know matrix multiplication, it is very easy to find. Solve it and tell me the answer. Yes, time up. Answer please. Okay, let me solve. I am not wasting the time. Let me solve. Yes, we need to find a square. What is a square? A square is actually a into a, which is equal to the matrix that is 0, 2, 2, 0 into 0, 2, 2, 0. I need to multiply this, right? Yes, first row, first column, we know that. To get the first element in the first row, first column, we need to multiply like this, first row, first column. So 0 into 0, 0 plus 2 into 2, 4. Next, to get this element, since this is a 2 by 2 matrix, this is also a 2 by 2 matrix. As a result of that, the resultant matrix will be a 2 by 2 matrix. So I am framing a 2 by 2 matrix. Yes. Next, first row, second column, 0 into 2, 0 plus 2 into 0, 0. Next, second row, first column, 2 into 0, 0 plus 0 into 2, 0. Yes, second row, second column, 2 into 2, 4 plus 0 into 0, 0. As a result of that, the final frame you will get this as 4, 0, 0, 4. So this is the answer for a square, correct? And you got the correct answer, Nevin. That is option D is the correct answer. Very good. Since you got the answer, let's move on to the next question, not wasting the time, right? Yes, this is the question. Read the question carefully and do reply with the answer. Please do write these questions also, okay? Please do write these questions. If you don't have any idea, please reply that I will explain. Without wasting the time, I will explain. Okay. Now I will explain. Listen. A diagonal elements of a skew symmetric matrix. What is the peculiarity of the diagonal element of a skew symmetric matrix? For that, we should understand what is a skew symmetric matrix. As I explained in the introduction frame, to create a skew symmetric matrix, what we need to do, consider a matrix, take the transpose of that and just take the difference of these two, you will get a skew symmetric matrix. Let me solve it. That means I am considering a matrix A as 1, 2, 3, 4. By taking a direct example, we can verify what is happening. Next, I am going to take the transpose of this. That means the transpose means 1, 2, 3, 4. Next, I am going to take the difference of this. So I am taking the difference. As I said, on taking the difference of the matrix and the transpose of it, you need to get a skew symmetric matrix, right? So I am taking the difference. On taking the difference as 1 minus 1, 0, 2 minus 3, that is minus 1, 3 minus 2, that is minus 1, 4 minus 4, that is 0. On checking this, this is the diagonal element. As we can see here, the diagonal element of a skew symmetric matrix is always 0. Correct? So let me see what happens. Yes, clearly even are all zeros, are all equal to some scalar k, that is wrong. Can be any number, that's also wrong. None of this. Yes, we know that this is the correct answer. The diagonal element of a skew symmetric matrix will be always 0. So for this question, A is the correct answer, and it is correct, Navy. I hope the idea is clear, right? So let's move on to the next question without wasting the time. Here goes the question. Okay, let me solve. Listen. If A is equal to 5x, y 0 and A is equal to A transpose, then x is equal to 0, y is equal to 5, x is equal to y, x plus y is equal to 5, x minus y is equal to 5. Let us see what happens. So A means, yes, this is 5, x, y and 0, correct? This is A, which is equal to A transpose. It is clearly given that A is equal to A transpose. So if this is A, I am going to take A transpose. What is A transpose? As 5, x, y, 0. From this frame, we need to calculate. We need to take a frame. Yes, listen. Here, as you can see here, 5 is equal to 5, no change for that, 0 is equal to 0. Here we can say that x is equal, because both are equal metrics. Since the order of these two metrics are same, both are equal metrics, then we can say that from this frame, x is equal to y. X is equal to y. Because x is first row second element, second column element. Here also y is also first row second column element. So x is equal to y. That's the frame we are getting. In here also, second row first column element is y. Here also second row first column y element is x. So here also we are getting the same frame, y is equal to x. So from this we can conclude that the condition is that x is equal to y. So for this question the answer is B. X is equal to y. Answer. Clear? Good. Good, Nevin. So let me shoot out the next question. Here goes the question. All are very important questions. Please write these questions. After that, you need to reply. Okay, let me explain. Listen. If a matrix A is both symmetric and skew symmetric, if a matrix A is both symmetric and skew symmetric, then matrix A is. That means they are considering a matrix and they are saying the condition that in order to be a matrix to be a symmetric and skew symmetric, first of all we should understand what is the difference between symmetric and skew symmetric. As I explained in the introduction frame, symmetric matrix means on taking the transpose of a given matrix you need to get the same matrix. But what is the difference between symmetric and skew symmetric? For skew symmetric also, here we need to take the transpose of the given matrix, but after that we need to take a negative from that frame, then only we will get the same matrix. Okay. So the problem here is this condition can be satisfied only if the possible elements in that matrix are zeros. If all the elements are zero, there is a possibility for that. There is a possibility means it is possible. That means symmetric and skew symmetric are equal for a given matrix. Otherwise, it will not be possible. So we can't initially reject a scalar matrix. It is not possible. Scalar matrix means a diagonal element other than one or other number. We need to get the same number. That is what we call a scalar matrix, right? So, so that's not possible. Second one, a diagonal matrix. That's also not possible. A rectangular matrix. That's also not possible. Yes, a zero matrix of order n by n. It should be a square matrix. So a square matrix, and at the same time it should be a zero matrix. That's the condition. I hope it is clear, and very good, Nevin, you answered it correctly. Okay. So let me move on to the next question. Always remember that you should write the question as well as the option in your notebook before finding the answer. Okay, because all these questions are important for the examination. So here goes the next question. Okay, I will explain that. I will give that frame, that is Aij is equal to 13 into mod minus 3i plus j mod. Okay, absolute frame. Then now it is easy to solve, right? Solve it. Answer please, taking too much of time. Yes, I will solve. Listen. A23 is what we need to find. That means we need to put I is equal to 2 and j is equal to 3. So A23 is equal to 13 into mod minus 3 into, in place of 5 we need to put 2, right? Plus in place of j we need to put 3. Yes, which is equal to 13 into mod 3 into 2, that is minus 6 plus 3. Correct? So here listen, which is equal to 13 into minus 6 plus 3, that is 3, right? So minus 6 plus 3 is 3. So actually minus 3 it is. So modulus of minus 3. Modulus of minus 3, that is 3 itself. So 13 into modulus of minus 3, that is 3 itself. So 13 into 3, actually the answer is 39. There is a typographical error, I think. The answer is actually 39. It is not there. So I am removing this option and I am considering this as 39, and this is the correct answer, right? This was a typographical error. So please do write this and write it carefully. I hope this is clear, right? Is that clear, Navin? Is that clear? Okay. Okay. The next question, please. Okay, let me solve. Let me check. Yes, clearly given. It's a 2 by 2 matrix. X plus 3y, y, 7 minus x, and 4. This is equal to. So equality matrix frame is given, right? 4 minus 1, 0, 4. Let's see the options. As x is equal to minus 1, y is equal to 7. 7 minus 1, minus 7, 1, 1 minus 7. So listen, from this, first of all, this is a frame that x plus 3y is equal to 4. So we can't directly find this frame because both two variables are there, two unknowns are there. So I am taking this condition, that means 7 minus x, that is equal to 0, right? So from this we can say that x is equal to 7, because on taking this minus x to the right hand side it becomes plus x. So 7 is equal to x. That means we got x is equal to 7. So if x is equal to 7, by directly looking into this option, we can say that B is the correct answer, because that is the only possibility where x is equal to 7. But we need to clarify it, then only we can complete it, right? So I am moving on to the next frame also. So x is equal to 7 plus 3y is equal to 4. So 3y is equal to 4 minus 7, that is minus 3. As a result of that, you will get y is equal to minus 1. So that's the correct answer. X is equal to 7, y is equal to minus 1. Correct. So moving on to the next question. Please write this question, very important. Yes. Find the value of x, y and z if x plus y plus z, x plus z, y plus z. Actually, this is a matrix of order. It has 3 row and 1 column. It's a 3 by 1. This is also a 3 by 1 matrix. So from this frame, we know that x plus y plus z is equal to 9, correct? What we require, we need to find the value of x, y and z. 4 options are given. Yes, x plus y plus z is equal to 9. Next is x plus z is equal to 5, and the last one y plus z is equal to 7. These are the frames given. Yes, listen. First of all, I am taking this condition, y plus z. So on substituting this y plus z, this as 7, then this becomes x plus 7 is equal to 9, correct? I am explaining that once again. Clearly given that the value, the sum of y plus z is 7. We know that x plus y plus z is equal to 9. In place of y plus z, if I am putting 7, then this becomes x plus, in place of y plus z is 7, x plus 7 is equal to 9. If x plus 7 is equal to 9, then x is equal to 9 minus 7, that is 2. So we got x is equal to 2. On looking into this option, it has 2 possibilities. First one is C and the second one is D. Both has the value x is equal to. So next frame. Yes, the second frame I am playing, that is, we know that x plus y plus, listen, x plus y plus z is equal to 9. Here, x plus z is equal to 5. So x plus z is equal to 5. That means in place of x plus z I am putting 5 plus this y is equal to 9, correct? In place of x plus z I am placing it 5 plus this y is equal to 9. So we will get y is equal to 9 minus 5, that is 4. So from this frame, it has 2 possibilities, y is equal to 4 and this is y is equal to minus 4. So most probably this will be the frame, y is equal to 4. Correct? Let's check with the next frame also, because we know that x plus y plus z is equal to 9. And from this we got x is equal to 4, sorry, x is equal to 2 and y is equal to 4. Plus z will give 9. So 4 plus 2, that is 6. On taking the 6 to the right hand side, 9 minus 6, that will become 3. So we will get z is equal to 3. So we can say that C is the correct answer, not D. So for this question, C is the correct answer. Very good, Nevin. Okay, I hope it is clear. So you should note these questions, very important. If you completed this, let's move on to the next question. Since you got the answer, I think you completed this. So let's move on to the next question. Other ones, if you are watching this, just pause the video and write these notes. Okay, so let's move on to the next question without wasting the time. Here goes the question. Yes. Answer please. Taking too much of time. Okay, listen, I will explain. I think it is correct, Navin. Let me solve. Listen carefully. If A is equal to cos alpha minus sin alpha cos alpha, then for what value of alpha A is an identity matrix? We know that for an identity matrix, the matrix, if it is a 2 by 2, it looks like 1 0 0 1. This is an identity matrix, correct? Here a matrix is given. So in place of cos alpha, we require 1. In place of minus sin alpha, we require 0. In place of sin alpha, we require 0. In place of cos alpha, we require 1. So in place of cos alpha, we require 1. And in place of sin alpha, we require 0. Correct? Just compare this. To make it as an identity matrix, in place of cos alpha, we require 1. And in place of sin alpha, we require 0. If you know the trigonometric table frame, it is very easy to find, or it is very easy to answer, correct? The reason why is cos alpha. We need to think which angle of cos will give the answer as 1, which angle of sin will give the answer as 0. Both the angles will be same, and that angle is 0 degree, because we know that cos 0 degree is equal to 1 and sin 0 degree is 0. So we can say that 0 degree is the correct answer. So option A is the correct one. I hope it is clear, right? So let's move to the next question. Here goes the question. Solve it quickly and reply. Answer please. Yes, so I am solving this. Okay, listen. Given matrix A is equal to 3, minus 1, 2, 4, 5, 9, 1, 3, 4. Write the value of 3A22 minus 4A33. Simple question, right? 3 into second row, second column element. Here second row, second column element is 5, right? So 3 into 5 minus 4 into A third row, third column element. Third row, third column, this is 4. So 4 into 4. So 3 into 5, 15, minus 4 into 4, 16, 15 minus 16, the answer is minus 1, correct? So the answer for this question is C, minus 1, correct answer. Okay, the next question, we're not wasting the time. Yes, please. Yes, listen. If A is equal to, it's a 2 by 2 matrix, 0, A, 0, 0, then A raised to 16 is dash matrix. Listen. A is clearly given as 0, A, 0, 0. So we need to find what is A raised to 16. Whether it is a scalar, 0, identity or diagonal matrix. Right? Scalar means the diagonal element having same number other than 1. Right? But the number should be same in the diagonal frame, the diagonal section. 0 matrix means all the elements are 0. Identity matrix means the diagonal element should be 1. Diagonal elements means, diagonal matrix means the diagonal elements, only diagonal elements are there that may be different or same or like that, right? Okay, so let me check. So here A is given. From this frame, what I am going to do is, first of all, I am going to find what is A square. A square. Yes, I am writing this 0, A, 0, 0. A square means A into A, right? So 0, A, 0, 0. Let me solve. Yes, we know how to solve this, right? So 0 into A is 0 plus A into 0, 0. A into, then first row, second column. 0 into A is 0 plus A into 0, 0. Then second row, first column. 0 into 0, 0 plus 0 into 0, 0. Second row, second column. 0 into A is 0 plus 0 into 0, 0. As a result of that, we will get a 0 matrix. We will get a 0 matrix. We are getting A square as 0 matrix and we require A raised to 16. Listen, we know that A raised to 16 we can write like this, that is A square the whole raised to 8. We know that A raised to m the whole raised to n is equal to, that is A raised to m the whole raised to n is equal to A raised to m into n. We know that frame, correct? Like that. A square the whole raised to 8 means 2 into 8, that is 16. So we can write A raised to 16 as A square the whole raised to 8. We already know that A square is a 0 matrix. So a 0 matrix 8 times, it will be 0 itself, no change for that, correct? So as a result of that, we can say that it is a 0 matrix, a very important frame. I hope this is clear, right? So listen, please note this. So I hope up to this frame it is clear. So these are the important portions we need to cover for a revision frame. I hope this session is clear. If you feel that it was comfortable and it is very easy to follow, please do follow all these questions that we have discussed. So it's time to wind up the session. I hope this session was clear. Thank you very much. Happy learning. Bye.